So in this video we'll try to we'll find out eigenvectors of this square matrix A. So in our previous video हमने इसके आइगन वैल्यूज़ निकाले थे. सो आइगन वैल्यूज़ ऑफ ए डिस्क्रिप्शन में इसका दे दूंगा. आइगन वैल्यूज़ ऑफ ए वी calculated was -1, -1 and 2. So first we will evaluate eigenvector corresponding to eigenvalue -1. सो आइगन वेक्टर की डेफिनेशन क्या होती है कि इफ़ यू मल्टीप्लाई एनी वेक्टर विथ अ मैट्रिक्स ए द डायरेक्शन ऑफ दैट वेक्टर, क्योंकि एक वेक्टर क्या होता है उसमें मैग्नीट्यूड भी होता है और डायरेक्शन भी होती है. तो जब हम उस वेक्टर को किसी मैट्रिक्स से मल्टीप्लाई करते हैं तो डायरेक्शन ऑफ दैट वेक्टर डज नॉट चेंज. सो जैसे देख सकते हैं कि जब हमने ए को वी से मल्टीप्लाई किया तो वी हैव लैम्डा टाइम्स वी वेयर लैम्डा इज सम स्केलर वैल्यू. सो डायरेक्शन ऑफ वी विल नॉट चेंज. सो since we are interested in finding out the eigenvector corresponding to eigenvalue -1, so we replace lambda with -1. It will become a plus I into v is equal to 0. A plus I multiplied with v is equal to 0. जैसा कि हमें दिख रहा है कि A is a 3x3 matrix. So eigenvector will be a 3x1 vector. So we can assume that the three components of this is v1, v2, v3, and we have to evaluate value of v1, v2, v3. A plus I is A is given to us 0 1 1 0 1 1 1 0 1 1 1 0, and if you add I is an identity matrix. Since I is an identity matrix, A plus I would be this, and you multiply it with vector v1, v2, v3, which is equal to 0. So vector, there is only one vector v, and the components or the element of that vector is v1, v2, v3. So A plus I would become 1 1 1 1 1 1 1 1, all ones, and it is v1, v2, v3, which is equal to 0. So 0, here it's a vector, 0 is a vector. We can write v1 plus v2 plus v3 is equal to 0. So there can be many combinations which is satisfy this. So let us take one combination, that v1 plus v1 is equal to v2 is equal to half, and v3 is equal to -1. This is one combination that would satisfy this equation, right? And then can be many other combinations. So vector one of the possible eigenvector corresponding to, or you can say one 0 minus 1 1 0 minus 1 can also be one possible combination. So 1 0 minus 1, and then what we can do, we can normalize it. So that, so what is the norm of this vector? Norm of this vector is root 2. So one eigenvector corresponding to eigenvalue would be minus 1. Minus 1 so there can be many vectors. So one such vector is this. Similarly, you can find out eigenvector corresponding to 2, and for this what you have to do, you have to write a minus 2i and you multiply it with some vector v corresponding to this 2. A is 0 1 1, one 0 1 and 1 1 0. This is A. 2i is 2 0 0 0 2 0 0 0 2. When you multiply it with v vector, which is a 3 cross 1 vector, you will have minus 2. A minus 2i will give you minus 2 1 1 1 minus 2 1 1 1 minus 2 . So minus 2 v1 plus v2 plus v3 is equal to 0. v2 v1 minus 2 v2 v1 minus 2 v2 plus v3 is equal to 0. v1 plus v2 minus 2 v3 is equal to 0. So by solving these three equations, we'll get value of v1, v2 and v3. So let's try to solve this 1, 2 and 3. So 2 minus 3 will give us minus 3v2 plus 4v3 is equal to 0. So v2 will be equal to 4 by 3 v3, and what we'll do, 1 plus 2 multiplied with 3. 2 is the number and 3 is equation, right? Equation 2 minus equation 3. Here what we do, equation 1 plus 2 times equation 3. So when we do it, 3v2, it will give us 3v2 minus 5v3 is equal to 0. No, those it's equal to minus 3. Excuse me. 2. It was my bad. Minus 4. I think so. v2 is equal to no. 2 will multiply with 3 and then add. So 3 minus 3v3. So v2 is equal to v3, and when we just sum this, so I think I did a mistake. So v2 is equal to v3 we have got. So v2 is equal to v3. So this was a redundant thing to do. We have got v2 is equal to v3. So minus 2v1 plus 2v2 is equal to 0. We have replaced v2 with v3 in equation 1. So will yield, or equation 1 yields this. So v1 will equal to v2 equal to v3. So you can choose any v whose three components are equal. So we can choose 1 1 1, and we'll just normalize it. So vector eigenvector corresponding to 2 will be this, and eigenvector corresponding to -1 will be this. And since we are having -1 -1 2, so we can say this is one eigenvector and this is another eigenvector. So you can see eigenvector is not unique, right? But the direction of this eigenvector will be such that all of these are same, right? So not direction, the value, the eigenvector corresponding to 2 would satisfy the criteria that all the elements of that eigenvector must be same. So that is why we have just normalize it, so it becomes unique. Once we normalize it, it becomes unique, because you can take any value a. The norm of this would be root 3a, and if you normalize it, it will give 1 by root 3. That is why we get a unique, I would say, norm vector, or the eigenvector with magnitude 1 corresponding to 2, corresponding to -1, we can have this. And as I said, you can also have eigenvector corresponding to -1 as 0 1 -1, correct? 0 1 -1. So if you normalize it, you can have this. So you can have these 3 eigenvectors for the 3 eigenvalues.